Thanks for the kind introduction there. Definitely sounds way cooler than what we really are. But we'll go ahead and jump into it. So just really quick, we've got probably 100 slides in here. We're going to breeze through a lot of them, but it's a lot of content to cover in such a short amount of time. So we're going to export the slides for you guys to look at them later in a deep dive. But we'll
don't try to take all the snaps as fast as possible.
it'll be there for you.
Yeah,
we promise.
What's up?
He said skip a Discord.
Yeah, it'll be all over. We'll figure it out.
Yeah,
They've got it.
they give us a link to send it to. All right, so about me, based out of Newberry, Florida, so it's about 2.5 hours north of us, outside of Gainesville. Together, Ralph and I co-founded Mayweather Group, LLC, and VTEM Labs. Mayweather Group kind of serves as our physical exploitation brand, where we manufacture and sell high-end badge cloning equipment for physical security penetration testers, as well as do some training for government entities as well as commercial vendors. Soft veteran, love to do veteran mentorship. I've been in the security industry now probably a little over a decade. I got my first start at Fishnet Security after I stepped out of the military, which turned into Optiv. Led the attack and pen team there for a number of years, and I've led some smaller offensive security teams as well.
All right, Ralph May. I am Tampa native here. I work with Travis. Travis actually got me started in cybersecurity at my first B-Sides Tampa, right? Started there. I've wrote a bunch of tools, and I'll also co-teach the physical exploit class. I've been doing offensive security for about 10 years now, and also an Army veteran, so yeah.
All right, jumping right into it. So we're going to talk about some of our current projects. You get an idea of what we have developed, and then talk about how you can start doing development or building your own tools. And then we'll talk some hardware engineering. Ralph will talk about some software development, and we'll open it up for questions. So some of our current projects. So as we mentioned, we have two companies, Mayweather Group. So our primary brand with Mayweather Group is practical physical exploitation. A lot of this is embedded engineering, 3D modeling. We'll walk through some scenarios here and how you can get going with that. Also, we can produce our badge cloning kits or badge cloning gear for operational use in the industry. Hit on.
Yeah. So we decided to start a company called VTEM Labs. The reason we started a different company is because we actually started making SaaS products, right? Which is kind of an interesting twist and move, right? But it has a direction. So we ended up making two products, Spear and Arrow. Spear is a pen testing in a box platform, right? So we do all the way from scoping all the way to reporting, right? So it's kind of the whole life cycle of doing pen testing. So we took actual knowledge we got over the last 10 years and applied that into a product, right? So doing a lot of software stuff. And then the other product we made was Arrow. And another thing, trying to solve problems in our industry, which is remote testing devices. If you've ever done an internal assessment, you got to ship those laptops out, right? And there's a whole process. You can build it yourself, absolutely. But do you want to manage it? So we kind of built a whole platform around that. Very cool stuff. We're going to help during this presentation. We're going to talk about how we built those things. So if you want to go do those things that we've done, go at it.
All right, so where do I start? The why. You got to have a why for what it is you're doing, right? So what doesn't matter is if something already exists, right? So if there's a tool out there, I got this when I started building my badge cloning gear. Like, hey, this tool already exists. Why are you doing this now? So initially, my thought was, yeah, there's some great tooling there, but it doesn't meet the immediate needs of the team that I'm working on or the features that I have. So go for it, right? Another thing you might get when you tell someone you're getting ready to develop a tool, there's no real need for that. Who are they to say that there's no need for whatever tool you're thinking about in your own mind, right? Build a proof of concept, or at least mind map it, and then you can determine individually whether or not that's a viable product or useful to the industry. If it's not useful to the industry and it's useful to you, it's still worth building. One, you're gonna continue to grow yourself, both from a skill standpoint, but you're also gonna build up those repetitions when it does come time to build something that's maybe a little more viable for the market. So what actually matters is your why, right?
Yeah. So the other thing I just want to say too about building tools. I know in the industry we had a ton of open source tools that people build that we all use and they're really successful and stuff. So when you first start looking at improving that, also think about if you could improve the tool that's already out there too, right? Sometimes it's not the best plan and building it from the beginning does make sense, but building 10 different things kind of fractures sometimes. So look to contributing at first, and then if that thing still doesn't solve your problem, then look at starting something else.
So before you get going, you really need to define the problem, right? You can't build the right solution if you don't know what the problem is. So think about what it is you're trying to fix, and that'll kind of build out your roadmap for where you're going. Solving the wrong problem wastes time, resources, and adds extra features that you may not need. Add all those nice to haves in your roadmap. So if you build a huge product roadmap and you want to put all the features in it at one time and get it out to the market, you're going to be working on that thing endlessly forever. And at some point you got to figure out when good enough is good enough, and just go with it. So think about what you need right off the bat. Everything else goes on the roadmap for future deployments. Key points to consider: identify your pain points. We already talked about this, right? What's broken, inefficient, or missing. Clarify the scope. What are the constraints and requirements behind what it is that you're doing? What does success look like? Validate the problem. So gather data or evidence that the problem exists. Ensure that you're not just fixing a symptom. And we got a nice quote there by Albert Einstein. Things to consider. Define your costs. This will get you really quick. I could tell you right now, as someone that develops hardware appliances and gets them manufactured, it could get very expensive very quick, especially when you rush things or you don't go over all the necessary costs. It gets very expensive. So think about what your budget is. Stick to that budget. Things to consider: raw materials, electronic parts, custom enclosures, etc. Software tools and licensing. There's a lot of open source tools out there that you can leverage, but when you go to start selling these things commercially, you're going to have to go buy those more expensive commercial tools, so that you can have, one, the flexibility that you need, and two, you're not infringing on something else that somebody else has created that is helping you further yourself, right? Manufacturing, PCB fabrication, 3D printing, injection molding. Are you going to do that in-house? Are you going to do it contracted? I can tell you right now, I started out doing it by myself until we made enough money where I can start getting those things manufactured. So there was many nights where I was soldering 100, 200 boards just by myself until we got to the point where we can get things manufactured.
The other thing too is don't be scared to buy something that already exists if it solves the problem, right? Because the one thing that's not on there is time. Your time is actually worth money. A team's time is worth money. All of that costs, right? So when somebody's saying, hey, this is expensive, you go look at it. Yeah, I could build that myself. And then you look at all the time it takes to build the thing. It's kind of like essentially saying, I need a F-150, so I'm going to go build that instead of buying it, right? It might take a long time to do that. So.
Yep. Shipping costs and import fees. This is especially important now. I can't tell you how much ransom I just paid to DHL over the last couple weeks. I was not ready for that, and I was pretty upset. But be ready for that. Other things to consider: DIY versus outsourcing. So sometimes it might actually be worth it for some things. If you don't have the skills or don't want to invest the time in the skills, find someone that's good at what they do and maybe pay them to do part of your project. I can tell you right now, when you're running a business, you can't just spend all of your time doing R&D, manufacturing, all the fun stuff, right? You got to be able to go out and do sales. You got to be able to meet with clients. You got to have customer support. So think about what it is that you need to do yourself and what you need to outsource. Buffer for overruns. So 20 to 30% is typically what we expect to pay anytime we're doing any type of development. Yeah.
Yeah, if you're going to leverage open source tools to reduce cost, just make sure to put a credit in there, right?
Yep.
So.
All right, hardware engineering. This is where the bulk of the slides are going to be. We're going to run through it real quick as possible, as we want to have plenty of time for Q&A. But these slides will all be there for you guys that want to deep dive into them later on. Tools to get started. All right, so if you're going to do hardware engineering, you're going to have to jump on the bandwagon. I could tell you right now, you will get lost in the options of what's there for you to start designing PCBs. KiCad, Altium Designer, if you're really bougie, or maybe you work for a manufacturing company that's going to get you that license, or Easy EDA. I use Easy EDA as that's just what I got started on. It's what I kind of started building things with, and I'm comfortable with it. Not only that, I can go straight in there and look up parts that I want to use. Add them directly, and I'm not kind of jumping through hoops to kind of find what I'm looking for. I have tried KiCad since getting going with EDA and really doing a lot of designs and iterations. And for whatever reason, I keep going back to Easy EDA. Now, that's my personal preference. If you already started up on KiCad, stay there. Stay there. Keep with it. Got some funny jokes there. I'll let you guys read those later. 3D modeling software, there's a bunch out there, right? So if you're going to do this, I would recommend starting with Tinkercad if you've never designed anything before. If you want to make a cube, it's great. It'll also let you make another cube. But if you work with simple shapes, you can actually make some pretty complex things inside of Tinkercad. Fusion 360, it's free until you actually need it. Then it's pay to play. And man, oh man, do they make you pay. But it is definitely worth it as you can go back, design your sketches, and you start to extrude and move things around. You can go back and modify your sketches, and you're not rebuilding an ultra complex shape or part. There's other stuff that you can go out there and use, Rhino, Blender, SolidWorks. Again, we got some more funny jokes in there. Microcontrollers. So chances are if you're manufacturing a PCB, you probably got some ESP32 or what have you. You're going to have to kind of choose your fighter on how you want to develop. Arduino IDE is there and available to you. I personally like VS Code or Cursor. Much more prefer Cursor at this point as it's got the AI integration in there, as we like to call it, our assistant. We just send all of our dumb questions that way, and it tells us our dumb questions are dumb and tells us how to ask better questions, and it helps us solve some of our more complex problems. So give them all a look, give them all a try. This one's worth investing your time in to find the one that you actually do like. I would strongly recommend either VS Code or Cursor if you're doing anything with a microcontroller, as it has the platform I/O directly integrated, and that helps immensely with building, flashing, what have you.
I'll talk about this a little bit later on in the software stuff, but if you're not using VS Code, you absolutely should be as your editor. And if, again, as Travis mentioned, if you're not starting to use AI, you're going to get smoked. So.
Yeah. That's not to say let AI build your entire application.
Yes. Yeah, I'll talk about that too.
All right, hardware tools. How many people are into gear? I know I'm into gear. Former Army guy. I love my gear, right? So grab the essentials. You don't need to buy everything. You don't need to go ultra high end. I would say if you're going to invest in a few things right off the bat, a good soldering iron. If you're hand soldering, a hotbed or a heat plate. That will get you so much further, so much faster. And then one of these little rulers here for components, if you're doing PCB design, you can look down and you can size up a component and you can say, yeah, no, I'm definitely not hand placing that on a PCB. Let's maybe go with something larger like an 0805 size resistor. Also a bench power supply. I can't tell you how much I use my bench power supply to this day, almost 3-4 times a day at least, easily. And then a good set of calipers. .3D printing, buy once, cry once per year. This technology evolves so fast. I would recommend, if you're going to do this and you want to make money at it, maybe not getting one of the DIY 3D printer kits. You'll spend more time tuning that thing, fixing it while it is fun, and we're tinkers. We're not looking to build 3D printers. We're looking to build products that we could take to the market or to help us in our daily lives. So I personally, despite the commotion online, I do like my Bamboo Labs printer, and we will probably be buying an army of the H2Ds here, HD2s, whatever they are, the new one.
The new thing that they make.
Here in the near future. As it comes to 3D printers, research what it is that you plan to build, right? And then start thinking about the filaments for each one of those things. Each one has kind of their own little takes on it. PLA, prints like a dream, and it melts like one too. ABS, Smells like cancer, prints like disappointment. PETG, because your love for strong prints, but also stringing everywhere. It gets pretty ugly pretty quick. PETG, carbon fiber reinforced. My personal favorite, it's strong, heat resistant, and brittle, just like my patience when I'm printing it. So,
Who's got a 3D printer? Just use one, right? Yeah? Right, so just a little caveat with 3D printing, even the best 3D printer is going to have issues, right? Mm-hmm. So just kind of know that like, you can get a lot of consistency, but there's going to be an issue that pops up. It's a little more of like oiling a machine, right? Like it needs the right, what do you call it, inputs. It does take some kind of management to make sure it's still going to work right and print right. So just be cognizant of that. Just because you bought the best thing and then it didn't print right, maybe you have to make sure you're doing it right. So
don't think that because you calibrated it once that it's always good to go.
Yep.
Humidity changes, right? So anytime you get ready to go do a good print or something for use. Ooh, what happened? Oh, there it goes. We're back. That humidity will kick in, and you'll be like, I just calibrated this thing. Why does my print look like garbage? In Florida, definitely calibrate often. Also, what are those little bags called?
Oh, the decadent
bags.
Yes. Yes.
Put as many of those things, if you have an AMS in there, as you can possibly fit. That's my recommendation. If you're in Florida.
For anyone who hasn't 3D printed, the moisture in the filament is what causes issue, so we're trying to get it as dry as possible.
All right. Proof of concept to prototype. All right, so we got a little hypothetical project here, building an RFID reader, right? So what's our problem? We need to know, if we want to go build a reader, we need to know how to interface with the reader's Wiegand interface, as we know that a HID reader or whatever type of reader typically puts out a Wiegand signal. We need to know what voltage is that signal, and can my microcontroller support that voltage? How will we power the reader? So we got to solve for a power source. What we know that we want to use an OLED display, so we want to be able to see what's going on from a user standpoint. We're comfortable developing with an ESP32, and we want 2 buttons to navigate through the screen. So as we catch badge reads, we want to be able to arrow through, go back and see what we caught, and go from there. So what are our constraints that we have with our prototype? We'll be self-assembling, so SMD components need to be large enough for hand placement. Case will be mostly enclosed, so thermal aspect needs to be considered, and cost. We need to save money on components where possible, because these readers do get very, very expensive. Problem. So we need to know how to interface with the readers. I think this is kind of a duplicate slide there. So we have to go in and analyze things, right? So the way I like to go in and analyze things is I pull out my multimeter, right? And I'll just turn on the device and I'll hook up to the wire to see how much power is going out. We could tell that when the reader is just on, it's getting 4.8 volts out the data lines where the Wiegand's coming out. So we have to solve for that right there. If we pick our board or our ESP32, these T-Display S3s by LilyGo are incredible. If you don't have one, I strongly recommend grabbing one just to play with. But if we look at the requirements here, we can see that it operates. Oh, sorry, this is our reader. So our reader requires a 12-volt power supply, right? So we have to, one, power the ESP, right? Which is probably going to require 3.3 volts or maybe 5 volts input. And then our reader's going to have to solve for a 12-volt input. So we got to think about how we're going to get the proper power to each one of those without frying anything. When we look at our ESP, the output there, we've got some 5 volts pin headers, but that's output only when you look at the data sheet, right? So the only way we can really input on this one is to either go through the battery connector or directly to the USB Type-C input. So when we think about this, we got to think about the thermal aspects, right? So if we put 12 volts to a 3.3 volt connection, we're going to have to really step that down. And as you step down voltage, you're going to generate a lot of heat. So we got to think about where we step down from. I can take that 12 volt input and I can step it down to 5 volts. And then once it's on the board, it can step down to 3.3 volts. As we do this, we're going to look at what type of power we're going to use. So here, we're just looking at, for our prototype purposes, just a LD 1117. This is a low dropout voltage regulator. And it comes in different form factors, right? You can see this D-pack, you just solder that directly on. This is a bit larger. We can actually use that on a breadboard just to get going. So we do know that it supports an output current of 800 milliamps, and we can get it in fixed voltages of 1.2 volts out all the way up to 5 volts out. So as we look back at these readers here, we see that the reader pulls 250 milliamps, and our ESP32, it doesn't say exactly, but I can tell you that it's probably around 250 milliamps as well, depending on what you're powering off of it. So that's our solution for power. Now we need to look at the fault tolerance, or the ability to support 5 volt data lines coming off those Wiegand connections. As you look at the chip itself from Espressif for the ESP32S3, it says that the pins are not 5 volt tolerant. So that tells us that we need to put some type of system in place to drop our 5 volt signals coming off those readers down to 3.3 volts to support the reader itself, or the ESP itself. So how do we do that? One, we can use a logic level converter. So this will convert the signaling from high, so from 5 volts down to low, the 3.3 volts, and that's bidirectional. We don't really need a bidirectional communication with the Wiegand interface on a head reader. We just want to take that data, bring it in and process it. Only reason we would want to send it back to the reader is if we had another interface where we sent it downstream to the controller. So if we wanted to like replay a badge read at a later date, that's the only time we would really want to convert that back up to a 5 volt. So cons, requires a lot of connections and costs a bit more, right, to implement. Our option 2 is voltage divider circuit. This is probably the best way to go for our application, as we just need to receive data. We don't need to send it back out. Super cost effective to implement, and we'll talk about each one of those right now. So voltage divider, how do we do that? We're just using 2 resistors, right? So if we put a 10K resistor and a 20K resistor, we could take that high output at 5 volts and drop that immediately down to 3.3 volts, right? So with just 2 simple resistors. Here's some math on how to get to those points there. I won't get into the nerdy stuff too much, but pretty simple. If we were to do the logic level conversion, you would have to have a 5 volt power line going to a 5 volt power source. You'd have to have a 3.3 volt power line going to a 3 volt power source, so that you can determine or tell the logic level converter what was high and what was low. Then you would need to have 4 lines total for Wiegand, for data 0 and data 1, to determine the 5 volt signals path, and then the 3 volt signal path, and then you'd have to have grounds on both sides. There's a whole lot of connections that kind of go into that circuit. Over this one, we're just tying the ground on that 20K resistor and essentially altering the signal. Other things we'll need for our proof of concept, right? We'll need our momentary buttons so we can jump back and forth. We talked a little bit about the power requirements on the ESP32, where we need to supply 5 volts directly to the USB-C. So on this particular design, we're just going to hook a USB-C connector directly to the ESP32 for the powering, and then we'll need some screw terminals to connect everything up. All right, so as we jump into easy EDA, right, we're going to look at our data sheets. If you ever have a question, anytime you're pulling up a part, don't just go blindly look at another design that you've seen. Actually go look at the data sheet. 9 times out of 10, it's going to tell you exactly how to set things up. And if you follow that diagram, you'll be good to go. Also, they'll have some placement suggestions inside the data sheet itself. So when you go to design your PCB, you're putting it in a recommended fashion where noise might be an issue or what have you. So Again, components. Look at the size of the component to determine how much heat it might dissipate, right? So as we look back at our first slide, one of our constraints is that it's going to be an enclosed area. We want to take thermal into consideration. Here you can see what the thermal data looks like on the different size components of the same LD 1117, and you can see here that TO 220 has much better heat dissipation than some of the other ones. Right. All right, designing the circuit itself. So just be simple with it, right? Look at what you need. Here we talked about what we needed to do and how to kind of get there. Now we're just kind of mapping everything in our easy EDA in our sketch prior to moving that off into design world, right? So we've got our LD 1117. This layout looks a little bit different just because this component looks different inside of easy EDA, but for all intents and purposes, we still have our capacitors in the same orientation. We've got our voltage in. We've got two screw terminals here. That's what these CN1s are. That's for our power input and our power ground. And we're just labeling what that actually is. Here's our wiring for our ESP32. We've got our data 0, data 1. This is the low side. We've got our left and right buttons, and we've got some inputs over here. We're actually connecting the reader and the buttons themselves. And here only other things we need on this simple circuit is our voltage dividers. We got our high side, our low side, and we're just tying those two resistors together to pull down that current to the recommended current on each one of those data lines. Now's the fun part. So this is where we actually do our proof of concept, right? So get your breadboard out. I like to make sure that I have my power supply here. I set it to exactly 12 volts. Another reason why I love this power supply or having a bench power supply, I could see exactly what the wattage is. I can see what the amperage is that I'm pulling. This looks a little bit ugly, but I do have my power input here. This is my 12 volts are coming in. I've got my voltage or my level shifting circuits here. I've got my buttons plugged in, and everything's kind of orientated the way it should be. This left side over here is our 5 volt side, so we're bringing in our 12 volt. We've got our little guy soldered up here, which is dropping it down to 5 volt. We kind of see the circuit. Before we ever go and design our PCB or get it manufactured, we know that everything works kind of as intended. Some things to think about here. While we're not going to jump into actually designing during the talk, think about where things should be. On an ESP32, you've got these little Wi-Fi antennas. They don't like to have any copper anywhere around it. So even if I'm just doing a PCB to mount an existing ESP32 directly to the top, I'll still put a no port area. So if my antenna is going to be hanging right here, I don't want any copper back here. If it's sandwiched between two pieces of metal, that's going to, one, degrade that Wi-Fi signal, but it can also cause noise issues on those small microcontrollers. Inversely, anywhere that's not in that no port area, I always fill it with ground. Depending on how many layers of board you have, that ground works great for taking all that thermal, all that heat out and dissipating it. So this is just how I like to lay things out. Additionally, thermal vias, consistent everywhere. That again, if you have multi-layer boards, it kind of acts as a heat sink as it passes through the boards. Look at the component recommendations for layout, and it'll kind of tell you like, hey, put a bunch of thermal vias or what's recommended, right? Here's our logic level conversion. So we've got 5 volt signal all the way from here, and then we're just wiring it up exactly as we said we would to those parts where our ESP32 will attach. Here's the fully designed board, what it'll look like. Very simple design. We're not actually putting ESP32 components directly on it as we're using a pre-manufactured part. We just need to do the logic conversion and the handling of the power. Inside of Easy EDA, you're going to need a few things before you go into manufacturing. Your DRC. So this is going to essentially make sure that you didn't make any mistakes when running your lines. I would strongly recommend never auto-routing anything. That's an expensive mistake I made when I first started doing this. I was like, oh, they got an auto button, boom, off to the manufacturer. Nothing worked on that board, not a single thing. I went back, I was like, all right, well, I'm an idiot. I'm gonna go back and do this the right way. Manually route everything. One thing that I would say too, trace widths, by default, these things can be super small, right? So depending on how dense a board you're creating, you might have to have small trace widths. You can look up the minimum sizes. We'll talk about that here on your manufacturer. I like to make my trace widths as large as I possibly can for anything that I'm doing. One, it adds more conductance. Two, makes it easier to see, test, what have you. So you'll need your BOM, so that's your bill of materials. You only need this if you're getting the boards assembled. You'll need to generate your Gerber file. This is essentially the CAD file that the machines use to cut out your boards and then pick and place. Again, you really only need that if you're getting your boards manufactured. Just tells where those parts go. All right, what are your options for manufacturing? There's not a whole lot that I recommend. If you go to Osh Park, I don't believe they actually do manufacturing there. I think they just do PCBs. I could be wrong. I've used JLC PCB since I've started. Pretty quick, pretty fast turnaround. They're not exorbitantly expensive, especially for just PCB work. I would say that if you are going to get PCBs manufactured, tile those things out. So don't just do one part on one PCB. Put as many PCBs as you get, or as many parts on a single PCB as your money will go much further.
They're all in China, so just expect there could be tariffs now.
Yeah.
Pretty much all PCBs are made in China, Taiwan. They're just not made in America.
Understand their capabilities, right? So we talked a little bit about trace widths and spacing. So minimum trace width here for JLC PCB. Laid out right there, so 6.5 mil. Make sure you don't go below that. Otherwise, they'll try to manufacture it for you, but they're going to charge you a lot more for stuff. Impedance control. So if you are building a custom ESP32 and you've got you get a flash over USB. Impedance is a big thing, right? So you want to make sure everything's properly aligned there. So you can go in here and you can see the spacing and what have you as you build out your differential pairs. There's a calculator at DigiKey that I love to use for doing that. Panel. So we talked about panelizing things. Just hit panel by JLC PCB if you're going to go to JLC PCB, and your part will come up and you'll just say how many you want to go across and what the size requirement is for that. And it's essentially the same price as you would with only single board on a panel. All right, so you ordered your boards, you get it back. You're going to do this by hand. What I like to do is take a bunch of boards and kind of make a template out of it, tape them down real good, and then I'll take my stencil that I got from the manufacturer, just tape that right over the top. Here you can just put your solder paste down, scrape it across really good. As soon as you lift up that stencil, everything's exactly where it should be. Another thing that I like to use when it comes to manufacturing, maybe not on a board this small, but there's an awesome tool out there called Interactive HTML BOM. So you can essentially take your pick and place file and your Gerber, and it'll automatically map it. You can pull that up into a web GUI and set it up next to you so you know what part goes where and how many parts you should have for each of your builds. Soldering paste that I like to use is chip quick stuff. It's very expensive, expires really quick. So if you're gonna buy some, wait until you're getting ready to do some manufacturing at the house or wherever you're doing it. And then at the end of it, you're probably gonna have to toss it unless you're gonna do a lot of manufacturing right away. Here's our heat plate. Much quicker than hand soldering. You do your solder paste, use some tweezers to drop your components down, heat that thing up, and you can literally watch the solder kind of fall into place. All right. Hand soldered the remaining components, and here we have our somewhat finished product that lets us read badges. It's got a little clock built into it, what have you. Firmware design, we won't really touch a whole lot here, but as you've done any type of ESP32 development, there's libraries for everything. There's the chances you need to write a whole lot of complex code are very minimal. Go to those libraries and then go to the examples. The examples have just about every application that you could want to do with that library directly built into it. Take those examples out, modify them to your needs, and you're good to go. 3D modeling, keep it simple, stupid, right? So here, our Aero product, we have these imaging racks that we created. So we just took a bunch of those jet KVMs, put them up at a fancy angle, and mounted them into our racks. So we have them all in the same place at the same time. You can use the existing components. You can go on to, like for jet KVM, for instance, you can go find the product itself, get the step file, import that into Fusion 360, and you can build your parts essentially right around those existing parts. That way you have a nice snug fit or positive fit on each component. Now, don't overcomplicate the process. Start with small stuff, right? If you're going to build a bunch of really complex designs, what I like to do when I go to 3D print is I'll say, I want to make sure this fits, so I'll put a pause in my print, maybe 5 millimeters in, and I'll pull that first print out, grab my device, plug it in there. Is it a good fit? No, it's not. Let's go make this thing a little bit bigger, so that way I can get the whole part in there before I print this entire thing, which probably costs about $5 per print.
When I asked Travis to make this, I was like, hey, they've got the step file, you're good to go, right? He's like, no, I need the device. Like, you can't, like, you have to make sure it actually fits. I'm like, yeah, but it's already in the CAD. Like, it should fit, right? No. I think he printed out like a ton of these before it actually worked.
Yeah. There was probably 7 different designs before we landed on this one here. 45-degree angles, that's a big one, right? So when you do any type of chamfering, don't go beyond 45 degrees. Anything above 45 degrees will require some supports in some aspect. If you stay below 45 degrees, you won't need supports, and you just have a cleaner, more polished print. So that's just a little pro tip. 3D printing itself, we talked about this, dry your filament, calibrate your machine to the filament, and do it often. Add a pause in your prints, terminate the printing while dialing things in. Use the right nozzle plate, etc. So if you want to have a textured print, use a textured plate. If you want a smooth print, use a smooth plate. Think about those things in the design process, and that'll usually figure out where you need to go. Also look at the types of filament. If it's going to be outside, probably shouldn't use PLA. Think about where the weather's going to be, or where the device, whatever it is you're making, is going to be at. If you're ready to make mistakes, you're going to make a lot of mistakes. There's going to be a lot of plastic stacked up in your trash can as you get to learning this. Even when you're pretty good at it, there's still going to be a lot of plastic stacked up in your trash can because filament sucks. Embrace the process.
Embrace the suck.
All right.
All right.
Alpha, you're up.
Yep. All right, so I'm going to talk a little bit about software development. Okay, so who's used any SaaS products before? Probably everybody, right? If you go anywhere, they're everywhere. So we're going to talk about not necessarily developing SaaS products, but developing a web interface, right? Yeah. So, software. Do I need a web interface or do I need a CLI? Okay. There's a lot of tools out there that are just made with a CLI, or software that's made with a CLI, especially a lot of hacking tools. I love my CLI and it has its place, right? But if you're going to give that same thing to a mass market of people, they now have to learn what every single of those commands do, right? Has anyone ever tried to learn how to use Metasploit or any of the other big CLIs, right? There's a process that comes involved with that. Even if there's a huge documentation, now I need to know how the CLI works, right? Which is why when we browse the internet, we don't browse the internet with a CLI, right? There are some benefits, absolutely. So I'm not hating on CLIs. I'm just saying that we as a kind of a collective have decided that the web interface is where we're going to interface with our applications, right? Are people running my code, or am I running it for them, right? So here's another question when you're designing some software. Am I going to be using this tool internally? Probably make it a CLI, right? Save yourself a ton of time. But am I going to be giving this to other people? well, maybe I should spend the time to make the web interface because now the document, who's read the document on how to use their bank website, right? It's kind of self-explanatory, that's the point, right? And so that's another reason why it might be a good idea. Think about who's going to be using it, right? Who's your user, who's your intended user, and where will you put the documentation? Even when you do make a simple product, you still need some documentation. I've used products that I know how to use a web interface and I just can't find the button or something like that, and it's just not intuitive. That gets into actually building a product that is intuitive, but I'll leave that up to your discretion. And then also deciding how you want to license your software. All right, are you going to make an open source tool? Awesome. Decide how you want to license it. It's not going to be open source. What your plan is with that software thing. All right, so with that being said, let's talk about building a web application. All right, so web applications typically have a front end, or think about a modern front end to build your web application. You want to maximize your compatibility. So out of box, you want to be able to support mobile and desktop. People are going to visit whatever web application on a phone as well. So consider these things. Try to make it extremely customizable. Web apps can also be applications. So who's used Discord, right? That's just a big web app that's wrapped in an Electron. Electrons everywhere, right? Now, there's things that a local web app can do. It can interact with the file system. It can interact. It can use some more processing resources. But that you can make a interactive web app that runs as an application on a computer, right? Same with many iOS apps or Android apps or just web apps that have been rolled inside. Everyone loves JavaScript, right? That's a joke. Yes, when you start developing a modern web application, it's a ton of JavaScript, right? I remember the first not web application I made, I tried to make a CLI in JavaScript, and I hated my life, and I abandoned that project. I've gotten older, and I've realized that nobody's getting rid of JavaScript, and it's used all over the place, so here I am. When you're making your application, try to cover the most use cases. All right, so here is a modern web application stack. This is just kind of like the general gist of it. Essentially, you have a front end, which is going to be a JavaScript library. You're going to have possibly storage, like an S3 bucket, right? The reason you might use an S3 bucket is that your application doesn't have unlimited storage, right? You might want to be able to have big files on there. Let's think a PDF or something. You're going to have a backend. The backend can be part of JavaScript framework, think Node.js, or it can be an actual programming language, which we'll talk about that. You're going to have a database, some place to store data to reference, and then possibly an IDP, which is essentially an identity provider. So one thing you've seen, or I've seen, and I think is a smart way from a security standpoint, is just separating your authentication outside of your application. You could do that locally if you want. There's no problem with that. But if I use a IDP, then I can offload that whole task, and then we can think about that security from a separate standpoint, right? Also, a lot of these IDPs include a lot of other features that I then have to build inside the web application. With that said, we have a bunch of different front ends out there. If you have looked in the landscape, some of the big ones are React, Angular, Vue.js, Svelte, Next.js. The list goes on and on and on. There's tons of JS frameworks for building your front end. Many of these frameworks can also be the back end as well. Essentially, they can process server-side data as well as be a front-end interface, but they don't have to. Additionally, another thing that I've discovered is there's UI toolkits. So instead of trying to make a UI, you can use these toolkits to accelerate your process significantly. So this is all the buttons and the notifications and the drop-downs and all the other fancy stuff that makes a web interface look cool. You don't have to manually go build all of that stuff, right? Many of these libraries are, open source and free. Some of them, like Material UI, you've seen. Shadas, CN UI, there's a bunch of them out there. They're probably in applications that you've seen before, but you didn't think about it because you're just trying to use the app and you don't really care. That being said, let's talk about the back end. So you can also write your back-end languages like Golang, Rust, .NET, Python, JavaScript. I prefer Golang. If you want to get really like hipster with it, you can go Rust. Another really popular framework is .NET. There's a bunch of web frameworks in .NET. It's actually more popular than you realize. Also Python. I would probably avoid Python. That's just a personal opinion. I've written Python a lot, but as far as making a full stack web app, performance becomes a huge issue, right? And also where it gets ran. So if the person is you who is running it, use whatever language you want. But if you're giving it to other people, now they have to run it, and the dependency hell of Python is going to come to bite you, and now your documentation is going to get really big. And then also JavaScript. There's many libraries that essentially use Node on the back end, both sides. All right, and then finally for database, honestly, I don't even have an opinion on this. You could use SQLite. It's actually really fast. Like, it's incredibly fast depending on what you're trying to do. It just doesn't scale. So if you need to be a Facebook, SQLite's not going to work for you, right? Or if you have something where you need to make essentially like a redundant cluster of databases and stuff like that, it just doesn't scale. But it is very, very fast. Postgres is another one. MySQL or whatever the current open source version of MySQL, right? I think it's MiraDB, same thing. MongoDB, if you want to go with like JSON objects, that's another fun way to store data. Redis is also kind of thrown in there. A lot of people use Redis for acceleration. So what people don't realize about Redis is that all of it, it's a key value store, and all of it is in RAM. So it is designed to be really, really fast. So a lot of people use it in their web applications for some kind of caching, right? So they'll cache data in there, so your web application seems faster. There's also Elastic. You could technically use Elastic for kind of a database store, right? Many like Sims and other big products, they use actually Elastic when you're searching as like a database. That's where you're dealing with lots and lots of data, but you're not doing it in like a CRUD, which is essentially like an updating system, right? You're not trying to update entries. It would be a horrible application for that. And then finally, your identity provider. Again, local is not really identity provider. Essentially, when you make an application, you can save username and password inside of the database. That would be like a local authentication. But you can also use something like Auth0 or Okta, OneLogin, Zitadel. Some of those are commercial products. Some of them are open source, like Zitadel. There's other ones out there. I think Auth0 you can use almost for free for a lot of the different applications that you would be doing. The benefit of this is that they already include things like passkey, user password reset. They already include all the security of actually using bcrypt for the hashes and all the other fun stuff, right? And another really fun thing is that a lot of people, including myself, would like some kind of single sign-on where I can use my Office 365 across a lot of different things. When you use something like Identity Provider, you can implement that, right? Without having to code all of that. And now your web application just essentially gets a thumbs up that says, hey, this is the person they said they are. And then the application itself, right, decides what their permissions are inside that application. All they're getting is that they are who they say they are, and they go from there, right? Okay, so another fun thing that started to come out is like web framework backends. So let's accelerate the process even faster. So Firebase was the original one with Google, and then there's Supabase, Pocketbase, Trailbase. I feel like there's a theme here. But what these are in general is that they are a kind of like a quick start for a full stack web application. What they bring to the table is they already have user authentication built in. They already have some kind of database set up, and they're ready to integrate with a JavaScript language and then a backend language. One example of that is Pocketbase. It's written in Go. And what happens is that it's a single executable. It already has the ability to hook into a front end, Angular, React, whatever. It has a database, uses SQLite, and then it also has, authentication. So you can use local auth, or you can hand it off to an IDP, right? The benefit of this is that now I can just get started right away. I have something that's working. All I have to do is build the front end, bring those two together, and now I have a full stack web app, right? Trailbase, I believe, is the Rust version if you want to get hipster. All right, so some of the goals, building a full stack web application is what I recommend. I would avoid things like PHP. if you're writing in PHP, God rest your soul, today. So the really benefits is just to modernize the web application. The performance is significantly faster, and the ecosystems, all these libraries and plugins, and there's so many SDKs that you can plug into. Speed in the front end and the back end. So you want a framework that's quick, right? Something like Go is significantly faster than PHP, for example, especially when you want to interface with the actual underlying operating system or do some kind of function, right? You want security in the backend API, so all of your calls should have some kind of authentication check, right? Every single API request should be authenticated in some way, so consider that. And ability to scale to cloud storage or scalable databases, right? Another thing to consider. Depends on your application. You're running something local that just runs on the computer, I don't really need scaling. So just consider all of these things when you're kind of putting it together. Finally, here's just an example of a front end that I but I wrote for the Arrow device deployment. This is just allows us, so some of the cool things is that this just allows me to see resources from the device itself, right, and IP addresses. While this isn't amazing, what I didn't have to do is actually work very hard to get this data out, right? Because the full stack web application, meaning the Go binary, can query a command on the host or use some SDK, I was able to get this information quickly, and the front end uses an API to ask for that data, and a JSON blob easily shows up, makes it refresh, so it makes it really quick. All right, so who's heard of vibe coding? It's a vibe, right? Okay, so there are a couple different things you could use to vibe code or to code with AI. Cursor is one of the big ones out there. They're probably on their way to be $1 trillion unicorn. I don't know. Windsurfer, Klein, or other ones. Essentially, what is vibe coding? So vibe coding is using large language models to essentially write all the code for you, right? And the vibe part of it is that you're not really looking at it, you're just asking it to do stuff. And then you're like, all right, what does it did? Okay, it did that. All right, no, it didn't do it right. So you keep asking it back and forth, right? But you're not technically looking at the code, you're just kind of vibing it out. But I will say, I started using Cursor to write code, and if you're not using this, you're really missing out on what value it has to add, right? I would not be able to write half the amount of code that I've written so far without the speed of a large language model, and it's going to continue. When I first started, I know when I first started with coding with AI, actually with just AI in general, I remember the first like ChatGPT 3 or whatever, and you asked it questions, and everyone's, look, it's hallucinating. This thing's so stupid. It's never. This is a joke. It'll be next 20 years before this thing gets smart, right? But it was like less than a year, and it pretty much started stumping and getting faster and faster. And even over the last 6 months, I'm like, are they going to just keep dropping new versions? Like, it's just getting insane. I can hardly keep up. But that being said, though, it is getting smarter. It is getting really good at coding, right? And the reason why it's getting really good at coding is the kind of fundamental way that if you have an input and you know the output, it can keep going until it gets that right output, right? And AI is really good at that. So anyways, these are things to look at. They can help accelerate the process significantly. Using large language models is not free, though. So just note that the bigger models, once you start using them a bunch, it's going to cost money. Also, one last thing I will mention about vibe coding or coding with AI. All right, so if you just start and you have no idea what you're doing, this is going to blow your mind, right? You're going to be like, holy crap, it wrote something amazing. But eventually, you'll start to be coding and realize, hey, I need to change this one color on this thing, right? I know how to do it, but I'll just ask them to do it, right? And then it takes like 5 minutes for it to think about this whole thing, go back and write it all out just to change a color. My point is that don't get too lazy with this, because you actually slow yourself down when you ask it to do really, really simple tasks. It should be used for kind of bigger tasks. Also, if you don't want it to code it all for you, I would absolutely recommend asking large language models to help you design what you want to do, right? Playing out that whole design decision is really, really powerful. So, all right. I think that
we made it.
Yeah, we made it. All right.
All right. If anyone has any questions, I think we got a couple minutes here.
We got like 5 minutes.
Yes, sir.
I'm sure when you're building physical products, using social media to market it is huge, but apart from social media, what would you say is the next most effective way to get your product out there?
Things that draw your customers to it. So for us, we make physical products and we make it specifically for physical pen testing. So we have a physical training class that gets people hands-on with the equipment, which also drives a lot of sales. Yes.
What are some of the things that you focus on for like network security of your devices, making sure that they can't be used against the company?
Yeah, so what we do is very simple. So everything's kind of broken into purpose. So if it was hardware security where I'm putting processing payments, it's going to look a lot different than hardware security where I'm processing card data. So I like the ESP32 specifically because it's got onboard encryption. You turn it off, your chances are you're not going to compromise card data that might be stored on it. But as you go further into that, you might want to think about adding some type of additional onboard storage and encryption controls, and then penetration testing on top of it. What's up, buddy? Good to see you, man. Yes.
Where will these slides be available?
They will. We're going to send them to the con here in just a minute. Yes, sir.
How would I contact you to talk about the veteran portion?
Yeah. Hit me up on LinkedIn. It's just search Travis Weathers and V10 Labs. You should come right up. Just shoot me a note on there. Yep. Yeah, what's going on, man? How you been?
That was a really good talk, man.
Thanks.
Thanks.
Very nice to see you, sir.
Hey.
Thank you.
Whole fucking crew. Thanks. How are things?
Doing all right. Been testing for a few years, both of us, and then we're now both on the management side.
Yeah.
Right on. Right on.
Yeah, went into leadership now. So
Trying.
Sweet. How big's the team?
it's growing. We just did a huge hiring spree, but I think total, not including testers, probably like up to like 30-ish, like not including the tester, which was like 18 before. But yeah, no, we've been growing in our steady way.
Great. That's great.
How's you guys still doing all the same offerings or expanding?
RTOs. We're going to be doing purple clean. Is it next presenter? Yep. Perfect. Is it just you or is it someone else? Okay, amazing. So what I'm going to ask you guys to do. Hold on. If I can have you guys. It's all tangled. Okay. Put this in your pocket and then right up under your shirt. Okay. And then just hook it up right here. Okay. I might just have Katie. And same thing for you. Just yep. And I'm gonna come up. I'm gonna give you guys something. Just it'll be an email address just to send the presentation to after. So give me just a second.
First talking when you had a microphone at the top, I was like, absolutely not.
When you guys are done, you have a chance after you present. Just send the presentation to this email so we can have it and get it up for video.
Yeah, sounds good.
Thank you guys.
Yeah, thank you.
It's a whole lot of extra cable.
Yeah, wired up.
Okay, I'm gonna do the introduction real quick.
Say again?
I'm gonna do your introduction real quick.
Yeah, give me like 1 minute, okay? And then, Now I did it right. See if this works. Woohoo, first time. 1 second. Word. Caden, where you at? Say, don't worry about it the whole time. Just do like a couple shorts or something, okay? Make sense?
Yeah.
Yeah, go ahead. Whenever you're
Okay,
ready.
welcome everyone. This will be about Purple Team cheat code. Please welcome Tyler and Trey Gilray, two cybersecurity leaders from SIT with deep roots in both defensive and offensive operations. Tyler brings over a decade of experience in defensive cyber operations, while Trey leads an advisory emulation efforts and co-founded the Neon Temple, a hub for cyber collaboration. In their talk, Purple Team Cheat Codes, they'll share hard-earned lessons and practical strategies to strengthen your security program, no matter what team you're on. Get ready for actionable insights you can take back and implement right away.
Thank you. How's it going, everybody? How's B-Sides been so far? Great. Have you guys made it into a lot of talks or just kind of overwhelmed by what else going on?
A little overwhelmed.
This one's a lot. There's a whole lot going on. Say again?
I'm going to need to have no later.
I hear you there. So, as she said, this is our Purple Team Cheat Codes talk. Me and Tyler both, we work at Scythe. We'll do the whole Who Am I's here in a second. But this is kind of our thing, and this is a culmination of a lot of our experience over the last 10, 15, actually 17 years. We did the math this week. It's how long I've been playing this game. So we'll dive into this. Hopefully you guys will take something cool from it. Who are you?
Hi everybody, I am Tyler Casey. You see over here, I am the lead detection engineer over at Scythe and the deputy of Scythe Labs. Over at Scythe, I perform the blue team side of our purple team engagements, which if you don't know, we're going to talk about it here in a second. I've been in defensive cyber operations for about 10 years now. Before I came to Scythe, I was on a cyber protection team, both as an active duty Marine and as a federal civilian. What a cyber protection team is, yeah, devil dogs, anybody out here? What a cyber protection team is, there we go. Too bad you got a Mets hat on, my guy. But we would essentially deploy all around the world for targeted threat hunting and incident response. So I hope to take some of those lessons I've learned and pass it on to you guys today.
Who am I? Hey, I'm Trey. See, faces match. I swear that's me. I'm the person. So I am the lead AE engineer over at Scythe and the head of Scythe Labs. So really what that means is a lot of the content you see coming out from our organization, our threat emulation plans, webinars, workshops, all that kind of stuff, that's me, Tyler, and our team. My background, 17 years at this point in IT and cyber, from anything basic IT networking, RF and SATCOM. That got me into the whole cybersecurity realm when the 2013 apocalypse happened. And from that, defensive and offensive cyber operations. Now we're here sharing some knowledge with you guys. If you care about alphabet soup, I hold some of these and a few others. You can check out my LinkedIn if you would like to know more or just connect. So let's actually get into the part you guys care about. You don't really want to hear about us. Contents today. So if you've never heard of Purple Team before, actually, you know what? Who's been a part of a Purple Team engagement before? Or done anything purple teaming? Okay, cool. So almost half. Yeah, a lot more than yesterday. So we'll talk about kind of what it is. We'll give you a quick primer on the basic tenets, concepts, things that go into purple teaming engagements. From there, we'll actually dive into some of our, we'll call them cheat codes or combos. From the red side, the blue side, a couple of good general tips. And then we can open it up for questions and then let you guys get on to your next talk. So we're going to start off with what is it anyways. So at a bare minimum, if I was to boil it down, it is a collaborative, milestone-driven methodology. Now, we use this methodology to bring red teamers, bring your blue teamers, and bring everybody else that's involved in the organization together to collaboratively improve your overall security posture and defenses. That's the whole goal here and what we're trying to do.
Main point on that, collaborative, right? We're going to talk more on it, but a purple team engagement is very, very different than a typical red team or pen test that you might do. It's blue and red working together. Again, the point of all of this, offensive, defensive, purple, silver, which I just learned the other day, all the colors is to build up your defensive posture. That's why all of us are here and have a job.
So what is it? How does it work? So put a fancy little graphic diagram together to kind of basically explain what's going on in a purple team engagement and how it starts. Obviously, you've got to have some reason to do it, something you're afraid of, right? So we're going to utilize threat intelligence based on whether that happens to be a ransomware group, a specific threat actor, hacktivist, anything like that, and pull all of that data we can about them, find true actionable bits and pieces of intelligence and the behaviors that they exhibit, and use that to test your organization. So we're going to actually, based in realism, based in facts, we're going to take that information and throw it against you and see how it sticks. Maybe you see something cool happen. Maybe you notice you've got some gaps and you've got some things to fix. That's kind of what we're trying to do here. But once we gather up all of that threat intelligence, we've decided who it is that we want to emulate or we're trying to protect against. We've got to go into the preparation, decide how we want to do that. Whether that's going to be just kind of like a collaborative purple team exercise where it's just the red team you guys have in or internally, your security analysts, and just kind of letting them go at it. Maybe you do a hybrid tabletop exercise where you're bringing in the whole organization. We've had some pretty good experiences with this, with getting everyone involved, not just your analysts and the outside red team, but your legal team, bringing in PAO, your C-levels management. Because it's one of those things there is all of those people are involved during an incident, right? So why are you practicing without them? We bring them all together, we prepare that whole engagement and make sure they're participating. Once we've prepared, right, we've got to do the thing. Run the exercise, see how everything plays out, and then everyone's favorite part, and especially Tyler's favorite part, lessons learned. What'd you take away from it? Notes or it didn't happen, right? These are the core tenets and the things you need to run an engagement when you think about purple teaming. Benefits you get. I swear we've only got like 2 more slides talking about this, then we'll get into the stuff that's actually fun. First and foremost, and realistically, the best part of this is training your defenders. We always like to say you don't want the first time you're responding to an incident or putting your procedures into play being during an incident. That's really that's poor timing, right? And does anyone have to actually do that? Who's doing IR? Who's working in any of that kind of space? You've had to respond and not knowing where your SOPs are? Not knowing what tools you have accesses to? That is the worst feeling in the world. And that's the whole point of this, is to avoid that. Improving communication. This is something that's often overlooked. Running these kind of engagements and doing these not just annually, but frequently, getting everyone together and actually running through a real problem is going to ensure, one, you understand how your tools work, your SOPs work, but your people know who to talk to. If you're in the middle of an incident and you need to put out some kind of statement, get something word out through legal, that doesn't just go to a lawyer and then they say you're good to post it on Twitter, right? That's not how things work. Do you understand that process right now? Do you think your team does? These are all of the kind of things you're trying to accomplish. So it's not just making sure your logs go where they go. You're also ensuring that you know who to talk to, when to talk to them, what frequency, and making sure everyone's working together. The part that most of you in the room actually might care about is identifying those gaps. Maybe making sure that all of your endpoints are rolling logs up into your SIEM, SOAR, XDR, crazy data lake combo, whatever you've got going on right now. Most people think, oh yeah, that's going, it's fine, we're good. Until you're not. Until drift happens or something changes, somebody turns something off, and now you're not getting anything. I know that sounds very catastrophic, very drastic. We've seen it happen. We've been in engagements and had teams go, oh yeah, no, we're fine, we're gonna crush this. And then turn around, we do one or two things, they're like, did y'all do anything yet?
When you guys getting started? When
Yeah, it's like, well,
start looking?
what do you mean? It's like, yeah, we've been doing stuff all morning. Like, oh, we've got a problem now. And just finding out for the first time, their logs aren't doing what they think they're doing. But then lastly, probably one of the coolest parts about running a purple team engagement is showing immediate value. Bringing someone like us in, or even internally running your own engagements, you have everyone talking together. It's not like a pen test. You sit through a pen test, you bring in someone from outside, they throw the book at you, they write up some report, hand it to you, and then do one of these, right? And just disappear. The value comes later, maybe when you can read that report, interpret it, maybe do an out brief with them. But all of those are ifs or wins, right? If you're doing it live in a purple team engagement, as we're executing and doing different behaviors in your environment, you're able on the spot to determine, hey, are we seeing alerts? Are we getting logs? Is this stuff ingesting properly? Or do we have a visibility gap? Is something wrong here or misconfigured? And on the spot, you've identified the gap, you can provide a solution. Sometimes, depending on your organization, if you don't have a crazy 6-month change control review board, you maybe fix it on the spot. So now it's not even a problem.
Not only just to fix it on the spot, like for example, if you know that you're missing a log or you don't have one of the buttons turned on your EDR that enables some other kind of logging, if you have the ability to in your organization, you can turn it on, rerun that same procedure we just ran, and know immediately if you're able to see it. There is no waiting until much later or thinking that this is going to find it. You can prove it. And that's really the true benefit of this collaborative nature of the purple team.
The end goal being to get to something like this, an operationalized purple team. This is just a kind of a more expanded diagram to show you everything that kind of goes into it, all the stuff you would think about. You're not here to learn about purple teaming 101, so I'll just leave this up here for a second, then we'll move on. But wanting to show you kind of what the actual end goal is and everything you need to do this.
Yeah. And to hit on this too, I know that Trey kind of talked about it, but not all purple teams are technical. You can have tabletop exercises. Maybe you're not ready or there's no trust yet, which we'll talk about how important that is in a little bit, but maybe they don't want you to deploy some emulations in production or demo or prod or wherever. You can run these like almost thought exercises, tabletops with all of the stakeholders, with your blue, with your legal, with your red, with everybody, and think what's going to happen almost as a precursor to actually performing the emulations on the endpoints. And that's a great way to build trust, get an idea, start to see some value before you even get to putting hands on keyboard.
All right, so what it's in it for you? To summarize the last 5 slides, a quick TLDR. Personnel, that continuous training and adaptation to the threats you're actually facing in real world. You're not just having someone throw some crazy obscure exploits or using something they tested out on Hack the Box yesterday against your organization. You're actually seeing how you stand up to the threats you're going to face in real life. From a processes perspective, you're going to be able to streamline your processes, your procedures, everything that you guys do, the typical operating stance of your teams by running these engagements. Then lastly, tooling, reducing noise, improving your response times, triaging less tickets. I know that's got to sound great to someone, right? So that's really what you're kind of looking to get out of this. So enough about purple teaming. Let's talk about the more fun stuff. So we'll dive a little bit into red team combos, then I will let Tyler talk about some blue stuff.
Who understands what Game Shark is? Okay, all right.
Who in here's too young to have ever used a Game Shark? Oh, man. Yeah.
It's like an AI for video games.
It's a whole different world now. Whole different world now. But cool. It still did the transition. That's fun. There's a really weird Easter egg in the slideshow. Like, I just cleared all transitions and it still decides to do it anyway. But anyways, first one, assume breach. And truly, whether or not you're doing these kind of things as an outside consultant coming in to help organizations or you're doing it internally, assume breach. Your customer or your teams are going to thank you later. Now you might be saying, well, why? And oh, that doesn't feel like a real test. What's going on here? That wouldn't have happened if we wouldn't have assumed breach. That's not the case at all. We've seen it quite a bit. You can assume breach and save a ton of time, effort, money, and frustration on just trying to potentially get that initial impact, right? Who in here's had a user in the organization get phished before? More than half the team. Probably all of you in here, some of you just don't want to admit it. Who in here has read an article recently about a major organization that got hit by a phish or some other kind of attack like that that caused a full compromise?
Who's heard in the last hour that phishing is 100% effective? Right?
Yeah.
We all know it.
So if you know that's the case, why waste the time? Why waste the money? Go ahead and assume one of your users is going to click the thing. You can avoid spending 6 weeks and the money it takes to have someone come in and do this for that kind of time frame, and just already say, hey, I'm the user, I clicked the link, we have a problem. And you're good. You're saving yourself so much frustration and time.
How long do you guys think an average pen test engagement or red team engagement is? How many days? 5, 7, 2 weeks, maybe? How long do you think?
Exactly.
They won't do it until you quit paying, for sure. So let's say it's probably a week, maybe 2 weeks, right? How long do you think a purple team engagement is that we do? About 4 hours?
Yep.
8 hours?
On average, 4 hours to a day. If it's an organization that really wants to do some crazy stuff, 2 to 3 days.
Yeah. Taking the assumption that you are going, it's not the if, it's when, right? Everybody's heard that, I'm sure. Taking that and really internalizing it and utilizing it saves you not hours, but days, but weeks. That's a ton of money. That's a ton of time. To hire an outside consultant to come in and do all the stuff that you are pretty sure is going to happen anyway, you can really save yourself a lot of time and money just by assuming the breach.
This one here, this is actually really cool. We've got a little side note incident story for this one. But just crafting a good story, something like utilizing CTI drops within your Purple Team engagements will really change how it all flows, how your teams interact, and what they're trying to accomplish. From this perspective, we've done this before, and so I'll go ahead and get into